Hello students, I am Kausalya. Today we are going to solve example 1.10 part 2. That is, we are going to draw the force voltage and force current electrical analogous circuits. So, from the previous video, we had obtained the differential equations of mass m1, mass m2 and mass m3, and I had replaced these displacement in terms of velocities by using these expressions. So finally I had got the value as these are the expressions in terms of velocities, right? So now I am going to draw the force voltage analogy. So as we all know that regarding in force voltage analogy, this M1 should be represented as L1, M2, L2 and M3 as L3. And again this B1 should be represented as R1 and here B2 R2, B3 R3 and B23 should be represented as R23. And the next one is K1 and here K1 should be represented as capacitance. So here I have to write it as 1 by C1 and 1 by C2 because while writing expression I will be using only 1 by C1 here. And again this voltage and this voltage should be represented as respective currents here. So here I am writing as I1, I2 and I3. Right. Those who are watching this video first time, kindly go and see the force voltage and force current electrical analogous video. Right. Then only you will get a clear idea. And the next one, now I am going to draw the respective electrical analogous circuit. So just consider your first equation. Here in this first equation, here you are having a mass M1. So this M1 is represented as L1 here. So just draw an inductor. Right. And the next one is you are having B1 and B1 is represented as R1 here. So just draw a resistance here. So this is your L1 and this is your R1. And next one you are having K1 and this K1 is represented as a capacitor. So just draw a capacitors here. This is your C1, right? And the next one is you are having a B2, that is B2 is nothing but R2 and this B2 is common between your loop 1 and loop 2. So here just draw a resistor and this resistor is common for your first loop and second loop. So let this resistor be your R2, right? And finally we are having B3, that is we are having another resistor and this resistor is common for loop 1 and 3. Okay, let this be your first loop and this be your second loop and the outermost part will cover your third loop. So here I am drawing a resistor and this resistor is nothing but your R3, right? So this is your first loop and let the current flowing through this first loop be I1, right? So this expression consists of 5 parts. So here your first loop consists of 5 elements, 1, 2, 3, 4, 5 and here also 1, 2, 3, 4 and 5, right? Now consider your second expression. So in this second expression, again here we are having an M2. So this M2 should be represented as L2 here. So just draw an inductor here. So this is your L2, right? And the next one is here we are having a B2, that is a resistor R2 common between loop 2 and loop 1. So this resistor R2 is already drawn here, so you can leave it. Next one is you are having another resistor, that is B23. We are having R23 and this R23 is common between your loop 2 and 3, right? So this forms your loop 2. Okay, this is your loop 2 and this is common, this R23 is common between loop 2 and loop 3. So here just draw a resistor, this is your R23, right? And the next one is again you are having a K23 and this K23 is common between loop 2 and loop 3. So K23 is nothing but a capacitor here. So just draw a capacitor. This is nothing but your C2, right? That is K23. Here you have to write it as C23. and this is your second loop. Let current I2 flows through this loop, right? Again, the second loop consists of how many parts? That is second expression, 1, 2, 3, 4. So again, in your equation you are having, that is in your diagram you are having 1, 2, 3 and 4, right? Hope you all are clear with this. And the next one is we are going to draw the elements which forms your third loop. So here in this third loop you are having an M3. So M3 is nothing but it should be represented as L3 here. So here just draw an inductor. Let this be your L3, right? And the next one is you are having B3, that is R3. This R3 is already drawn here, so you can leave it. And the next one is B23. B23 is nothing but your R23 which is already drawn. And the next one is K23. K23 is nothing but 1 by C23 and that is also already drawn here. So the thing is just you have to complete this circuit. That's it. And this is your, here let the current flowing through this loop is I3. Right. So our third expression consists of 4 elements, right? So that is 4 elements. Here you are having 4 parts. That is 1, 2, 3 and 4. Here also 1, 2, 3 and 4. Right. Hope you all are familiar how to write force voltage analogy. Now I am going to write the respective expressions. So while writing expression, consider your loop 1. So in loop 1, let the current flowing through the inductor, that is the voltage drop across the inductor, is given by L1 into di1 by dt plus again I1 into R1, that is voltage drop across your resistor. And the next one is voltage across the capacitor is given by 1 by C1 into integral of I1 into dt, because in this part of the circuit we are having only current I1 which flows through it, right? And the next one is consider R3. In this R3 there are 2 currents flowing, that is one current is I1 and another current is I3. So here you have to write it as R3 into I1 minus of I3, because here we are considering loop 1, I1 should come first, right? And the next one is we are having an R2. So again through this R2 the current I1 is flowing as well as current I2 is also flowing. So writing the expression you should write it as R2 into I1 minus I2, and this entire expression is equal to 0 because here we are having no source, right? That is no voltage supply here. So this forms your loop 1 equation. Next one is considering loop 2. So when you consider loop 2, again here we are having R2 and this through this R2 there are 2 currents flowing. One is I1 and another one is this I2. So here I have to write it as R2 into I2 minus I1. I2 should be written first because we are considering loop 2. And next one is consider R23, and through this R23 also there are 2 currents flowing and one is your I2 and another one is your I3. So here you have to write it as I2 minus I3. And the next one is this capacitor. So here you have to write it as 1 by C23 integral of, again the current is I2 minus I3 into dt, and finally you are having an inductor here. So here you have to write it as L2 into di2 by dt, which is equal to 0 here. Again in the second loop there is no source voltage, so here we are making it equal to 0. And next one is consider your third loop here. So through this third loop, again while writing the expression for loop 3, here you will be having, that is L3. So L3 into di3 by dt, right? Plus again here you are having a C23. So again 1 by C23 into integral of, here we are considering our third loop, so I3 should be written first. So we have to write it as I3 minus I2 into dt plus, again we are having R23. So R23, and through this R23 also the current flowings are, one is I3 and another one is I2. So here we have to write it as I3 minus I2, and finally we are having an R3, and this R3 is common for I3 and I1. So here we have to write it as R3 into I3 minus I1, and again this equation is equal to 0 because here there is no source voltage, right? This is your respective force voltage analogy. Hope you people understand this well. Thank you.